So it says, given the following information, determine which lines, if any, are parallel and state the postulate or theorem that justifies your answer. We've already done this a little bit, so this should come pretty easily. 3 and 7 right here. I'm going to use pencil so I can erase my marks. Okay, so angle 3 and 7, if we turn it this way, you can see that they're alternate interior angles. It also means that if they're congruent, line B is parallel to line A, or A is parallel to B, because the alternate interior angles are congruent. So what we're going to write for number 1 is line A is parallel to B, and the reason is alternate interior angles are congruent, but we'll just say alternate interior angles. Okay, number 2, it says angle 9 is parallel to 11. So 9 and 11 here, and again, I'm turning it sideways, and you can see that 9 and 11 are corresponding angles, and it also means that line A is parallel to B. So here we're going to say A is parallel to B, and the reason is corresponding angles. Erasing my marks again. Okay, the next one is saying 2 is congruent to 16. So here's 2, here's 16. We don't have to turn our paper this time. 2 and 16 are alternate exterior angles, and that would mean that line L is parallel to M. So we're going to write L is parallel to M, and 2 and 16 are alternate exterior angles. Number 4, this one looks different. It's saying 5 plus 12 is 180. While we look at angle 5 and 12, they're consecutive interior angles between line L and M. So consecutive interior angles do add to 180, and if they add to 180, that means line L is parallel to line M. So L must be parallel to line M, and the reason is consecutive interior angles. Okay, whoa. Okay, now the next ones we are using some algebra. The algebra seems to be pretty easy for most people. It's like how to set it up that gets kind of tricky or challenging for people. So just looking at, let's say, number 6, I have alternate exterior angles here. Based on the theorem, alternate exterior angles are congruent. So in this case, you would set these expressions equal to each other. So 3x plus 10 equals 4x minus 10. Right, so since those angles are equal, you can set these equal to each other to find x, and that's what it asks us to do. So, anyways, subtract 3x from both sides. We get x equals 20, and that is the answer to number 6. Number 7, I'll go back to number 5. Number 7, alternate interior angles are congruent. So again, I'm just going to set these equal to each other. 6x plus 4 equals 8x minus 8. And then solve for x. And I get x equals 6. Okay, so that's what you do if they're equal to each other, but what if they aren't equal? We know that consecutive interior angles add up to 180. They aren't equal, and we can also see that they aren't equal. Notice that this is an acute angle, this is an obtuse angle. There's no way those angles are equal to each other. But what they do is they add up to 180. So we can write 2x plus 6 plus 130. So we're adding those two angles and putting them equal to 180 degrees.
And then we combine like terms.
Correct. Combine like terms to get 2x plus 136 equals 180. Subtract 136 from both sides. 180 minus 136, cheating off myself, is 44. Divide by 2. X equals 22. Okay, we aren't going to work out every problem, but we will talk about how to set it up. 8, you would set those equals, so it would be x plus 6 equals 4x. Number 9, we're going to solve out. That doesn't have a relationship as we outlined with theorems, those two angles. There's no name for them. But what we can say is that corresponding angles are congruent. So if this is 7x minus 5, then this one must be 7x minus 5. And these two make a linear pair. So these would add to 180. So 7x minus 5 plus 5x plus 19 equals 180. Then 7x plus 5x, now we're combining like terms. And this one doesn't come out exact. Comes out, we'll round it to 13.83. Number 10, we're not going to work it all out, but those are consecutive interior angles. So for number 10, to set it up, you would do 3x plus 10 plus 5x plus 18, and then you would put that equal to 180, and you could solve for x that way. So as you're doing homework problems, just look back at these examples, and if you find one that's similar, you can solve it the same way. Okay, this one's not too bad. Honestly, it's not too bad. Okay, so we're going to work through this proof. It says angle 1 and 2 are complementary. So looking at the picture, that means 1 and 2 add up to 90 degrees. So I'm making a little note for myself there. Then it also says that BC is perpendicular to CD. So that means that's also a 90-degree angle. What it wants us to prove at the end of this is that BA, this line right here, is parallel to CD. Well, what I see right here, and you may not see it right away, is that I have a transversal right here that's just not drawn out all the way. And if a transversal is perpendicular to one line and is perpendicular to the other line, then I must have parallel lines. So that's what we're going to be showing in our proof. First, it says BC is perpendicular to CD. That was given. Then it says angle ABC equals angle 1 plus angle 2. That's angle addition postulate. Number 3, angle 1 and angle 2 are complementary. That was the part of the given, so that's just given. Then it says measure of angle 1 plus measure of angle 2 equals 90 degrees. Well, if 1 and 2 are complementary, they equal 90 degrees by definition of complementary angles. Number 5, it says angle ABC equals 90 degrees. Well, if measure of angle ABC equals measure of angle 1 plus measure of angle 2, and measure of angle 1 plus 2 equals 90, then measure of angle ABC must equal 90. They're actually using transitive property.
What does transitive mean?
It means, I think I used this example. If Simon's the same height as Paxton, and Paxton is the same height as Billy, that's a stretch, then Simon must be the same height as Billy. That's transitive. And not a stretch for long though, Billy. You're like a foot taller than you were last year.
I am.
Yeah, literally, that's crazy. BA is parallel to BC.
No, perpendicular.
Oh, perpendicular. Thank you. BA is perpendicular to BC. That would be definition of perpendicular. If this is 90 degrees, then it would be perpendicular. Definition of perpendicular. And then it's saying BA is parallel to CD. That's a perpendicular transversal theorem. Whoa, okay. Perpendicular. Oh my goodness. Transversal. Is it shaking up there? Sorry. Theorem. That's that. Okay, so a couple things about the homework. Homework 3-5 is on Schoology just as normal. I also, last week we did Chapter 3 proof practice on like Thursday. I noticed that a lot of people didn't get to it or didn't finish it. So I reassigned it for today. So after you're done with homework 3-5, jump onto Chapter 3 proof practice and complete it. If you've already completed it, your grade is still as it was before, so some of you probably already have a 10 out of 10, but if you don't have a 10 out of 10, if you have a 4 out of 10, or you never started it, jump onto Chapter 3 proof practice and get that done as well. If you finish both homework and Chapter 3 proof practice, then work on Khan Academy. We have practice test tomorrow and test on Friday. So you can get a laptop, bring it back to your seat, let me know if you have questions.